What is science? Science is a way of knowing and understanding the natural world. All scientists, as they are gathering data, know that the information they gather is tentative, which means it's subject to change, based on new evidence. Scientists are constantly critiquing and revising experiments they make. An important thing to remember is that science only seeks to understand the natural world. It doesn't seek to understand anything supernatural. Science doesn't seek to disprove anyone's religion or beliefs. Science only seeks to understand the natural world, and science itself is benign. An example of this is Fritz Haber, the Haber process. Now, that was created to manufacture bombs, but it was used in agriculture and it's probably saved the lives of about 1 billion people. So it's not the science, it's just what you do with it. We develop better understanding through evidence. If it can be reproduced, others can test it too. In science, a law represents what happens repeatedly. It's a what. What? What? A lot of times in science, laws will have mathematical formulas attached. In science, a theory is an explanation of how something happens. It's a mechanism. Quite often people say it's just a theory, meaning a guess, but in science that's not what a theory means. In science is an explanation of how this repeated phenomenon occurs. What is the mechanism? What caused that to change? Theories can change based on new evidence. Science is open to revision and critique. An example of this would be gravity. We know gravity exists. Stuff falls back down and then falls on the floor. We can also mathematically calculate the force of gravity. However, there's also a theory of gravity, which is when you introduce Einstein, relativity, bending of space-time, things like that. The scientific method is a process or steps we take to produce reliable results to answer a specific question. A hypothesis is a prediction of what I think will occur. It's a specific if-then statement. An example would be, if I put my fruit smileys in water for 24 hours, then they will expand to 150% of their original size. It's specific, it's measurable. I have the numbers 24 hours, so I know how long it's going to take. I have an amount of time that my testing will take, and I have the percentage in my results. So I think a certain number will happen. This lends itself to an experiment. Experiments collect qualitative data, which is data that is just a description like blue or squishy or slimy or milky, adjectives, basically. There's also quantitative data, which is numbers. Don't forget your units, because if you say you have 5.7, 5.7 what? 5.7 inches, 5.7 tomatoes, 5.7 jelly beans. I don't know what it is. By the way, don't use inches. Metric. An independent variable is what you change to find the effects in your dependent variable. In this case, my independent variable is soaking my gummies in water. The dependent variable is the thing one measures, so the measurement will be the size of the gummies. In science, you also have a control, which is something you don't change in your experiment, so you have something to compare your results to. In this case, we'll have identical gummies sitting off to the side that were not submerged in water for 24 hours. So we start an experiment with an observation. Maybe you observe that after your little kid chews on a gummy, for a while it seems to have a greater volume. That's an observation. You might get an idea that maybe water will affect how big it gets. So you do research. This could be looking up other experiments. Maybe you give some fruit smileys to a little kid, and when they take them out of their mouths to share with you, you notice that they seem like they have more volume, but that might be the disgusting factor, so who knows. You may even do some research online to find out if other experiments like this have been made before and see what their results were. Research means finding out more about the topic, more about the thing you observed. After your observation and your research, you form a hypothesis. A hypothesis is coming up with an explanation. It's testable and falsifiable. Then you conduct an experiment. Before starting my experiment, it looks like my smileys are about 1.52 centimeters in diameter, or that they have a radius of 0.76 centimeters, and that the height is about 1.21 centimeters. Using pi r squared times height, that gives me a volume of 2.2 centimeters cubed. Then you make a second observation. Were you correct? Then you might do more research and do another experiment. And an example of this could be if we researched what salt water would do when we put gummies in there. What would that do to the volume? Maybe that'll be my second experiment. I don't know. We'll see. Sometimes you can keep going in this loop of revising and going back and re-experimenting and revising your experiment. You may find flaws in your experiment and then have to redo it, only better this time. But that's what science is, it's discovery. Finally, you have a conclusion, verifying or refuting your original hypothesis. You might also have more data that you add to it. You may have learned things along the way. Okay, it's been 24 hours, and you can see that there is separation of the dyes, and it kind of formed a layer. So here's our gummies soaked for 24 hours. See, a lot of the dye came off. So now the diameter is about 1.60 centimeters, or it has a radius of 0.80 centimeters, and the height is about 1.28 centimeters, giving it a volume of about 2.57 cubic centimeters. This is not what I originally expected. This is about 117% of the original volume. I expected 150%, but that's okay. Sometimes when we do experiments, we like to get a little bit of extra data. So here's the mass of a gummy that hasn't been soaked, and the mass of one that has. You can see it actually lost mass, which I thought was surprising. So I compared it to some other gummies just to make sure I had an average. So I was able to get the density. Originally the density was 1.27 grams per cubic centimeter, and then it became 1.05 grams per cubic centimeter. So it was less dense. Then after the gummies had been sitting out and dried for a little bit, I decided to get the volume of the dried out gummy. The dried out gummy had a height of about 0.89 centimeters and the diameter of about 1.18 centimeters, or a radius of 0.56 centimeters. That gave it a volume of 0.88 centimeters, and then if I take the mass, it has a density of 1.47 grams per cubic centimeter. The last step is to share your results. Science is all about sharing and collaborating so other people can repeat the same experiment. Through science, we can get a better understanding of the world around us. Science is all about observation and discovery and learning about the world around us. Science is amazing. Science rules. Dependent variable. Variant variable. Yes, variant variables. Can you hear them yelling? Crazy kids. In science, theories can change. Whoa. Bouncy, 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 bouncy. Your observation and your natural world. Open to, what's it called? Revision. That's the word. Science is open to theories? Yes. Hypothesis. To produce,